Hi, my name is Hannah, and today I'm going to be going over Physics 2212 Lab 1, which is charged tapes. To introduce the experiment, I would like to first go over the concepts that will be present. First, electric charge of objects can be positive, negative, or neutral, and there can also always be an excess charge on an object. Coulomb's law will also be covered because it is used to help us determine how much excess charge is on one piece of charged clear tape. That is the purpose of this experiment. The result gave us a charge of tape that was 9.8 e to the negative 9 coulombs. That charge was also positive, which means that there was a deficiency of electrons in the tape. Some more background on this experiment is that items can gain a deficiency or excess amount of electrons. An excess amount of electrons means that the item would have a negative charge. Deficiency in electrons would mean that there was a positive charge. Excess charge range can be from greater than the charge of 1 electron to less than the charge of a mole's worth of electrons. So this means that the final result that we receive should be between 1.6 times 10 to the negative 19 coulombs and 1 times 10 to the 5. We must use this experiment to determine a precise charge that is present due to the fact that this range is so large. Now diving into how this experiment is actually completed is first taking a 20 centimeter piece of tape and sticking it to a flat surface. This becomes our base tape. Then on top of that is placed another 20 centimeter piece of tape marked with a U. The U tape should then be quickly removed from the base tape, and that should be hung from a vertical surface and made sure that the tape is attracted to the hand. This is due to the fact that we want to make sure there is an electric charge built up on the U tape. This process should be completed one more time to make sure that we have 2 sets of U tape. Once we have 2 pieces of U tape, we need to first place one of them on top between 2 different standing objects. This will make a bridge with the first U tape. Then underneath that bridge, there should be another U tape held beneath it. This should make the top U tape float. Once this occurs, record the distance between the 2 tapes. The measurements needed for this experiment included the U-tape's length, which was 0.2 meters, as well as the width, which was 0.019 meters, and a linear density that was 1 gram per meter. Some assumptions that were made during this experiment was that no air resistance was present, that the tapes could be used as point charges, and that the tapes were the same charge. This is represented in the model listed on the right. As you can tell, there is no air resistance present. Both tapes are listed as point charges, and the only forces are the force of gravity and the electric charge from both tapes. Now diving into how we will actually use these numbers, first we will determine the force of gravity on that top tape. That is going to be equal to that linear density times the length of the tape times gravity's constant. Then we will have the fact that the electric charge is going to be equivalent to the opposite of the force of gravity, which gives us once again that 0.00196 newtons. The distance between the tapes that was measured during the experiment was 0.021 meters. With that and the force of the electric charge known, we are actually able to apply both of those into our Coulomb's law, which gives us a charge of 9.8 times e to the negative 9 coulombs for our tape. The deficiency in electrons can also be calculated by knowing the tape charge and the electron charge, dividing the two and giving us a result of 6.12 times e to the 10 electrons. The ratio of electrons to atoms is also present, and it's 6.12 e to the 10 over 4.83 e to the 17. A GLOWSCRIPT model was used to produce these answers as well. As you can see, the script to the right shows all of the calculations, as well as the print statements and the object creation within the model. The code resulted in the following image, which was used earlier in the presentation. As well, there were also different quantities at the bottom that were calculated within the code. All of the numbers that were earlier stated were used within this code. Finally, I would like to answer some theoretical questions made from this experiment. First, what if electrons had a positive charge and protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? The answer to this is that nothing would change. All interactions would continue to be the same due to both signs changing and attraction and repulsion laws remaining the same. So if a negative and positive were both changed, they would still continue to attract, and a negative and negative would still repel, as well as a positive and a positive. It is important to not handle the charged tapes as little as possible because of the fact that when your hands touch a charged object, it acts as a conductor, which means that that charge will then flow into your hands and leave the charged object. Because of that reason, it is important to not touch the tape repeatedly. Thank you for watching. Have a wonderful day.